Just by way of introduction, I've been a member of the RASC since 1989. And the way I got involved was I had a friend in the RASC, who I found out was with the RASC. I saw him on the bus reading a copy of Astronomy magazine, and I had a copy of Astronomy magazine, and he goes, "Oh, I see you're reading Astronomy magazine." And I said, "Well, yes, actually, I've got a 60 millimeter refracting telescope at home," right? And where I got my telescope was in 1968. What happened on December 24th, 1968? Apollo 8. So on that day, Christmas shopping. So on Christmas Eve, 1968, I was actually living in the States. I was down there when my father was on the Air Force posting. And Apollo 8 went into orbit around the moon. They did 10 orbits around the moon. Okay, so they did 10 orbits around the moon. And I remember stepping out in my backyard thinking, I can't believe this. I'm standing out, I can see the moon, and there are people at the moon. And this is what drives me today. I still cannot get over that moment. So that was Christmas Eve. The next morning, Christmas Day, and we had a tree. And under the tree was this long, narrow box. It had my Sears refractor, 60 millimeter refracting telescope. It said, "See the rings around Saturn, 520 times magnification." What did I know, right? So I played with that for a long while, but I also ended up in the Navy, went off to sea for a number of years. So I was using actually the main telescope I was using was in my sextant because I navigated by the stars. If anybody can't see from behind, maybe come on over on this side. Does anybody want to shift seats now to work around from behind the camera there? Feel free to move. All right, so when I was at sea, I was navigating by the stars, but I always had this interest in astronomy, but I didn't know that people actually got together in clubs to do astronomy stuff. And it's when I met Dave Robinson on the bus and told him, well, yeah, like I kind of have a 60 millimeter refracting telescope. I hadn't had it out of my cupboard in like 10 years. And he says, "Oh, so what have you been looking at?" I thought, "Oh." I said, "Well, this and that, I haven't had it out in a little while." So he says, "Oh, okay." Next morning on the bus, "Oh, so did you get your telescope out?" I thought, no, I was actually busy. I was watching TV last night or something. So then the third day, he asked the same thing, and then it was the weekend. I thought, I'm going to fix his clock. So I took my telescope out. All the memories came back of the smell of the little plastic and the whatever bits and everything, the grease that was, that sticky stuff they had on the draw tube. It all came back to me. It was wonderful. So then on Monday morning on the bus, Dave gets on, and I said, "So Dave, were you looking at anything with your telescope?" He goes, "No, but I take it you were." And so he actually showed me which one was Saturn. I used to be able to find it with a star globe. I mean, I had, in the Navy, we have a star globe, and you do all these calculations to figure it out. Years later, I could have figured out, I could have told that's how I taught navigators at sea. You could actually just take a little simple star chart, or just buy before you sail, go and buy the latest issue of Sky News or Sky and Telescope magazine. You'll know which ones are the planets. You didn't have to use all your pointers, and it was crazy. So, but anyway, Dave told me which one to look for Saturn, and then I jiggled my very sturdy Mount telescope, and finally, no, is that it there? No, I don't think so. And then, oh my God. And there it was. And what I saw was, because I was playing with the draw tube, I'm looking in the eyepiece, but I could also see with my other eye an image of Saturn floating in the palm of my hand. So I wrote an article for Astronauts, our newsletter, Planets in the Palm of Your Hand. And I just joined the RAC with Dave and all that. And then I started writing about things that I observed. Anyway, I was so gung-ho with all of this. I was so excited by all this. When my daughter Emily, Bridget, my wife is sitting there, our daughter Emily, when she was 5 and in Sparks, I went and did an astronomy program for them, for her Sparks group. That's how I got started doing public programs. And then from there, I mean, the first ones were pretty shaky, I have to admit. I mean, this one's shaky enough as it is, right? I know what you're thinking, Tracy. Okay. So one thing led to another. So I ended up doing teaching family astronomy programs for all of the local communities in Ottawa. But I was doing for families. I was doing it for children's groups. I was doing for seniors groups. I was seeing all kinds of people. Service groups. I taught programs at the Mill of Kintail near where our club's telescope is. And eventually I got invited to become one of the astronomy educators at the Science and Tech Museum in Ottawa here, along with a number of people. Rob Dick was there. Tim Cole there was one of the educators. Paul Cloninger, you'll see him later today, and Sylvie Letourneau you'll see at the banquet. And that was great. You see different groups of people and you deliver programs in different ways. This thing that I have right here, and Bridget, she doesn't want to remember this thing, that's our homemade planetarium dome. You can see it's made out of cardboard. And you're going to find that the way I do things in a very low-tech way, because I don't like playing with high-tech because it always fails, right? You know, I went up observing one night with Gordon, I guess. We went up 2.5 hours and to some site up on the top of some airstrip on the top of nowhere, very, very dark. I just had a simple little scope there. That's the way I like to do it. And he had a full setup. So he was about an hour setting everything up, and none of the batteries worked. And that was the second time that had happened for him. So I'm always ready to go low tech. Bridget cut out these cardboards and then cut the seams. She creased these things along here so that she could fold back tabs. And we used at first we used bulldog clips along there. I'm hauling around like about 13 pounds of bulldog clips to put this thing together, but I would get my groups to help me do it. They helped assemble this from nothing. It was like a puzzle. They loved it. So if you can get your group involved in a way that you can control how they're helping you, right? Help. Then that's one way to do it. Chris, we'll go to the next one, please. I've got the clicker, eh? Okay. So here's my backyard observatory, and this is actually Bridget holding a pair of binoculars. So I've got it's an 8-foot square box with a dome on top. I've got an 11-inch Schmidt Cassegrain telescope in there. And what I like to do, if you can go to the next one, please. What I like to do in my observatory, one of the things I like to do is do the crater sketches, the lunar features, get out my pencil and that. And of course, as people will tell you, right, the more you observe, the more you see, but the more you go for detail, like, okay, start drawing, now you have to go back to the eyepiece to double check, oh, did I remember that right? Okay, check this, check that, and away I went. And one of the problems I had with this particular one, which I featured in a journal, the Royal Astronomical Society article, was I spent so long doing this, the Terminator started walking across on me, right? So I'm thinking, boy, this looks... So what I do is I take a reference photo through the eyepiece. I'm the world's worst astrophotographer.
Oh, no.
Oh, no, I've seen some of your stuff. So I take a quick reference shot through the eyepiece, and I don't look at it until later. And then I do my sketch, and that's why it's a little bit more Terminator here than there is here, because I was concentrating on this, and that's when some of the things I developed, I'll show you in a few minutes. That's why you have pencil and paper. You're going to be trying this yourself in a few minutes. Okay, we'll go to the next one. So one of the things that keeps me going is that I've been inspired by people. This is when Clyde Tombaugh came to visit the RASC, the first year I joined, 1989. My very first Observer's Handbook has the cover torn off, because I was just a new member, and it was, I guess they'd already returned. Am I supposed to be saying this?
No.
Oh, no.
Look at 1695 from me.
Colin, yes. No, it was an official handbook, something, yes. But anyway, inside the handbook, of course, there's a Pluto finder chart. And I think just a couple months after I joined the RASC, Clyde Tombaugh did his cross RASC tour for the Tombaugh Scholars Fund, right? Because you probably remember all this stuff. So I did a sketch of him from my seat. There it was all hunched over at the microphone, right? Did a little sketch, and I was very inspired by what he'd done. So I went up afterward and I said, Mr. Tombaugh, I said, thank you very much. I thought that was a really great presentation. I said, would you mind signing my Pluto finder chart in my Observer's Handbook? And he took the book like this, and he takes it, and he goes, no one's ever actually asked me to do this before. And there he signed that. So now I'm inspired. I want to find Pluto for myself. Well, that was 1989. This is, what does it say, 2001. I'd done a couple of false starts trying to do it. It was just, I wasn't set up properly to go hunting for Pluto. It was kind of like a half-energized effort at doing it. But then one night, I saw in the Observer's Handbook, there's, I don't have the section from 2001, but basically what I did was I did a plan of attack. Okay, I'm inspired by somebody, now I'm going to try it. All right, and this is part of what we're talking about here, is people see what you do and they're going to try it. So I went and I made a map. So and I numbered stars. So what I did was I took, say it's this star, that star, that star, that star, that star, and I knew Pluto was going to be passing through there. So, well, how do I make sense of all this? I'll make it like a street. So I put, here's my street, here's my house numbers, and we'll see which one's moving. So on the first night, right next to the word Pluto there, it was, I think I had a choice. It was either this one, or I don't know if there's one here or not. I can't see from here. It's one of those two must be Pluto. But I couldn't tell because I need to do what Clyde Tombaugh did. Basically, he took a photographic plate a couple of days later, and then you put the two plates together, and then you see which one moved, right, from plate to plate. So I did the same thing, but very low tech. My plates are very low tech. So the next night, I found out, oh, it wasn't that one over there. It was actually this one, and now it's in the middle. I said, I need one more observation. So and the way I was doing it, I was starting off with a low power eyepiece to find my field in Ophiuchus, and then I would go to the high power eyepiece, right? Because you can't find anything if you're zoomed right in at a 525 times magnification. So the next night I went out and I'm feeling good, but it was very, very warm. I'm just wearing a little pair of shorts. I'm dying. I've got a black hood over my head. I've got bug repellent on. I'm dying under this thing, and I'm working with a 10-inch reflector out in the backyard. This is before I had my observatory set up, or I needed to get the aperture I didn't have in my observatory. That's why I used a Dob 20-inch scope out on the lawn. So then I plotted a third position, and there it was. And to me, that was the most satisfying observation I've ever made, because I had to work for it. And it was great. So then I could see what the movement was, and I remembered Clyde Tombaugh's words, when he discovered Planet X, and he says, and I knew immediately it was well beyond the orbit of Neptune. I could hear his voice in my head. So if we go to the next one, please, Chris. So this is what we do in the RASC. I mean, Ken Hewitt-White talked about that so eloquently yesterday, didn't he? About what it means to be RASC. Well, look at this. We have people here, Deborah Saravolo, who was, and Mike Mogadam, who we've seen out here. That's getting involved in IYA, the International Year of Astronomy, in, 2009. So by participating with people and sharing with people and learning from people, there's Tim, and other people that we work with at the Science and Tech Museum. You learn together, you bring yourselves up. This was from the last time we had a GA in Ottawa. That was at Carleton University in 2006, which was the RASC Ottawa Center's centennial. And I was sitting at the back there, and there's Terry Dickinson talking during the panel discussion, but he's not on the panel. This is what was really great about this. I mean, we had panelists down below, but there he is, and he's getting into a discussion from the top, and that's what makes a panel work, of course, is I think the way it worked yesterday. People it's a participatory activity. So this is the whole idea of what we do with astronomy outreach, try and make it as participatory as possible. So if I'm going out to see, we could go to the next one, please, Chris. Depending on which group I'm going to see, I mean, you explain things in different ways. Now, this is an old magazine ad, right? Anybody like Doral cigarettes? But look at the way he's using that reflector, right? So what he's got the eyepiece, so it's the mirrors at this end, and of course the lens. So he's actually examining his belt buckle. Oh, don't laugh. Don't laugh. Canadian Tire. I had a catalog, which I still have at home, I should have brought it. And it shows a refractor set up this way with the eyepiece down this end, and it shows another telescope set up this way with the eyepiece down this way too. It was so that a refractor and a reflector, with the eyepieces down at the same end. And so I went to the store, and I wanted to show the manager this. I said, hey, and I look up, and the young guys who had set up the telescopes on display, of course, there was a refractor set up with the eyepiece this way. There was a reflector with the eyepiece down this way too. I said, this is the way it works. So what we did, and the manager was great. He said, let's make it right. We took the telescope down, we remounted it, got it all set up, and put it up, and he said, thank you very much. So a little bit of outreach that way can go a long way as well. If you go to the next one, now outreach means you have to be able to connect with the audience. So what the heck's in here? Oh, it's nothing, okay. If I don't have everything in plain view, I forget I've got it, it's terrible. This is Professor Twinkleboom, all right? He comes along with me for all my programs. So I started taking him when I was going to see the children's groups. But then I thought, what the heck? When I'm talking to the adults as well, they can get ideas for how they might want to go and talk to, if they're asked to go and present on something. So, and of course, he's called Professor Twinkleboom because what do stars do in the night sky? They go twinkle, twinkle, twinkle. What do they do when they run out of gas and they die? They go kaboom. Professor Twinkleboom. When I go to see the guides or brownies, I take Estelle. Estelle goes along with me. And the way I can always tell, and you'll notice that Estelle has her guide astronomer badge and her brownie space badge. So the guiders gave Estelle her badges. So this is a way that you can connect with your group by talk to them in a language they understand. Hi, Kim. I can always tell which one is Estelle because the other girls have their dolls there too. My dolly has one stray strand of hair. I used to always say, something like me. All right? Let's go to the next one, please. All right. A little bit of sketching, things you can do with a group of people. Sometimes you can do it as a very simple kind of activity. It looks technical, right? It looks kind of cool, but all you have to do is you say, well, if you go and say, draw the stars. I was doing this actually with a group I was teaching at Algonquin College in Pembroke. If you want to do just a quick drawing of the night sky, well, they start to do dots, 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 and you've got a page that just has dot, dot, dot. There's no reference. I said, orient yourself, anchor yourself to the ground. Put a line there, put some trees, and let's start. But now, how far up the page are you going to put that? You see where, let's see what we have here. Lost my pointer. All right. So we have the Big Dipper here. Or does anybody know the French name for the Big Dipper? The Big Dipper, huh? It's La Grande Ourse. That's why I'm wearing my Ursa Major shirt today, right? So it's Brian McCullough and friends this morning. All right. So we got the whole gang here. All right. So there's the Big Dipper. There's the two outside stars in the pot, pointing toward Polaris, the North Star. Okay. So, what I'm trying to let people know is this is how you start to locate yourself in the sky, so you can find things like M81, M82, and I did little sketches. But they're trying to figure out, well, how high up? Like I said, it's 45 degrees up. That's our latitude in Ottawa. So if you want to know what your latitude is, measure the altitude of the North Star above the horizon. So how do you do it? I said, oh man, I forgot my sextant today. So we used the one potato, two potato rule. And where did I learn the one potato, two potato rule? I learned it from somebody in Terence Dickinson's book, I think, where he talked about your arm, your fist, at arm's length, right, at the end of your arm. Well, my fist is always at the end of my arm, but you know what I mean, right? You stick it out. Subtends about 10 degrees of arc. So we do, from the horizon, we go one potato, two potato, three potato, and I get 4.5 potatoes to the North Star from Ottawa. Why is this handy? You're lost in the woods. But you're an astronomer. You can find your way anywhere. Want to know your latitude so you can do parallel sailing, right? So you can I know that Ottawa's at 45 degrees north latitude, but I'm lost in the woods somewhere. I'll just walk along 45 north until I run into Ottawa. Find the North Star, find your natural horizon, not above the trees, natural horizon, one potato, two potato, three potato, four potato. Oh, 5 potato, 6 potato. Yikes. I've walked a bit too far in one direction. So you can do the mental gymnastics. Did you walk too far north? Did you walk too far south? Okay, let's go to the next one. Setting up for a program. Now I come loaded for bear, and there's a reason for that. So what do you notice in this picture? I've got my this and that, and this and that, and this and that, and this and that. What else do you notice? Telescope, yes. What do we notice? Oh, wouldn't you know it? You got invited to go talk to the Brownies. You traveled to their camp. You were packing up for hours. You drove for 2 hours. And no eyepiece. In my telescope, in my teaching kit, if you go to the next picture, Chris, this is a kit that I used to take out teaching all the time. So it's a 70 millimeter Skywatcher reflector that I got from Focus Scientific. And there's an eyepiece in there. And I have an extra eyepiece in the bag. But an eyepiece in my teaching telescopes, the eyepiece is always in the focuser. It's not the best thing to be doing with an eyepiece, but you know what? You're not going to walk out to do a program without your eyepiece. All right? And I know people where that's happened, and oh no, now what do you do, right? You ask Estelle, right? Oops. Okay, let's go to the next one. It's the way you present things. All right. So I did a sketch of the crater Julius Caesar. There's the crater there on the moon. Well, when I would like to present something, I like to do it in a little bit of a offbeat way. So I told Bridget, I said, I'm going to wear sandals, I'm going to wear a toga, I slick down my hair. And Bridget's saying, you know what those astronomers are like? Half the people in that room are going to say, well, why are you dressed like that? I even had a tape recorder. I'm holding my little cassette recorder, and you know what I'm playing? I'm playing that Wayne and Schuster feature, Wipe the Blood from My Toga. What I had forgotten was that Tim, he's a bit of a card, as we all know, he had talked to me. He said, "Oh yeah," he said, "I'll be like Brutus, come up and stab you at the end. That'll be great." And I'm thinking, "Wow, I'm trying to focus here." Okay. So at the end, I did this presentation. Oh, and of course, somebody asked me. Somebody got up and asked me, "So, Brian, so why are you wearing a sheet?" I'm talking about the crater Julius Caesar. I'm dressed like Nero. Oh, okay. A1. Finished my presentation, showed, and I talked about the features of the crater, how wide it is and how deep it is, all this kind of good stuff. And then at the end, just as I'm closing down, I completely forgotten, suddenly somebody comes running out from the side of the stage. It's Tim with a rubber knife and attack me. And I go, "What the heck are you doing?" So watch who your helpers are. All right, let's go to the next one. Do things in different ways. Ingrid, I think you just walked in, didn't you? I thought I saw her walk in. This was, you do things, find a reason to do something. If it's a summer solstice, okay, so then when I was meeting chair, I said, well, let's have a dress like a druid night. And a few people responded. There's Stephen Norse in the back. He's wearing he's our photographer. He's wearing the, why are we dressed like that anyway, Stephen? Rick Wagner in the red, right? I've got Ingrid over on the side, right here. And here I am in my, okay, so it was summer solstice. Well, here it is, now it's coming up Halloween, right? So we had, let's have a pumpkin artwork contest. There's Peter, did his thing of Saturn on there. Let's go to the next one, please. All right, so the whole idea is the more you use things to connect and you do it in a little bit of an offbeat way, people tend to remember it. So over here, okay, so now, I mean, you can do things in much different ways. They're at the Science and Tech Museum during one of our Astronomy Day presentations. You get the moon map out, a piece of meteorite, talking about the dinosaurs. We'll do something down here in just a couple of minutes, all right? Going to see the beavers. When you go to see a group like that and you've got them doing, get them doing hands-on activities. I'll be showing you some of these in just a couple of minutes. When they're doing, because they're not going to sit there and listen to a 30 slide PowerPoint. It's like death by PowerPoint, and, right? You'll find it very quickly. You know what? Time. Let's cut the program. Let's do something. Including when I went out to see Gordon Webster, and I'll tell you about him and his daughter Julia, who's right there in a second. This is a group at Julius School, and we had just finished doing all our experiments and everything like that. And I wanted to get them up and moving, so I got my Irish whistle out. We did the moon jig. So they're all doing the moon jig there. Go to the next one, please. All right. So then we get into what we're going to be talking about here, this meteor impact demonstration. And thank you to Tara and Elias for helping there, and also Ruby and Julie for the help, and Charmine. Thank you. Charmine in the back there. All right, for getting us all set up here. Most people when they set up, we'll go to the next one. This is that was Alan Hildebrand showing me some of his Tagish Lake stuff there. But he talked about the KT boundary, the time after the impact, the 65 million year extinction impact. So this is what I talk about with my groups. I talk about how an asteroid or a comet came in, exploded, and the air pressure down. I show them on a map, which I have down on the floor there, where that happened. Okay, where that happened. And then if we go to the next one, please, Chris. This is what Alan Hildebrand gave me during his presentation as he was either the Ruth Northcott or Helen Sawyer Hogg lecturer in 2006. And he came and he went down to southern Colorado and he found this chunk of rock. It was like a loaf of bread. And of course he did the good geologist thing. He broke it off and smuggled it back in his luggage. But what he had was a section from the KT boundary, right? So below the KT boundary, it's a time when you find dinosaur bones. It's a time when dinosaurs roamed the earth. Above that, you never find any dinosaur fossils. So what he interpreted here was, so here's Cretaceous shale. Here's coal from the Tertiary period, more recently. Here's this stuff here. This is ejecta. This is several thousand miles away from the impact point over the Yucatan Peninsula. The mud. Mon Dieu. That shatter cone almost shattered. Here it is right here. Right? The mud is still as thick as my finger. And they say, well, what's it like? It's like if you took a mud puddle and you threw a rock and kasplat, and that's the kasplat. That's how you interpret it for young groups that know. They understand throwing a rock into a mud puddle, all right? You can use nice demonstrators like this. Kenneth Liu, right, from Vancouver Centre, brought some of these. Are these stress-relieving asteroids? I feel a lot better right now. I have to tell you, you should try this, right? You use these things to demonstrate how things happened. So I show them this, and when they can actually hold this in their hands, and this is a time when dinosaurs were walking the earth, and up here, no more. So it's just a way that you put things together, and you can do things like people going on the Holliford Crater tour tomorrow. Chuck will be talking about shatter cones. So this is a piece that we found. Did this come from Sudbury, Bridget? Okay, from Sudbury area. All right, so you see what and people start to now understand the force of an impact. It actually shocked the rock and realigned its molecules into these striations. So there are ways to do things. Let's go to the next one, please. So when I do my experiment, you got to get set up. I was a couple of minutes late, my apologies. I was trying to protect some of the stuff as it started pouring rain as we're trying to get it out to the car. Get everything set up, so and get your helpers. I had good helpers this morning, all right? And we got set up. We've got a nice little thing set up, and we're going to make a heck of a mess. It's going to be great, all right? But there's everything all set up on the side. Let's go to the next one. The way I do this, and I'm kind of spilling the beans ahead of time because I just want to explain how I'm doing things. You'll see that I've got pans of flour, okay, little aluminum pans. I put a disposable tablecloth down on the floor. And most people that I've had seen doing this experiment, they use pans of flour and they sprinkle cocoa on top. Well, after several rounds of kidney stones, and they figured out, well, I shouldn't be ingesting chocolate. But I was doing this experiment so many times that I'd be, even just a whiff of chocolate, I'm thinking, oh, I think I feel a kidney stone coming on, right? So I thought, well, what am I going to do? I'm going to change this up. Aha! So what I found was powdered temper paint. It's hard to find now, but you know, like in primary school, they would take the powdered temper paint, mix it with water, and you get the paintbrush is this big, and you go and you're an artist, right? That's what I sprinkle on top. Now, this is worthwhile doing it this way. It's much better than just working with the cocoa because what it does, it shows the order of events. So now, when we do the impacts, we can see there's green here, and now we see red on top of the green. We know that the green impact happened before the red one. And this is what planetary geologists do. They like to know the order of events. Let's go to the next one, please. Okay, and what I do is I use my little lunar lander, and I interpret the Apollo program on there. That's the leftovers of one of these experiments. And I'll tell you how I set it up there in just a moment. But you can see just in the pans, you throw a marble in, you can see the ejecta, you can see the white rim, how the geology on the rim of a crater is actually upside down, right? Because it's been poof, turned like that. You can interpret it right there. And I tell people, I tell the groups that I see, after they're gone, after we've done this with all the scouts or whoever, after you're gone, I said, we've cleared everything away. I'm going to look at this because when I see things through my telescope, when I see a line of ejecta going along and then I see, oh, it's interrupted and then it continues, why did that happen? There's probably a ledge there or some kind of ridge. It interrupted, right? It created a shadow point for the ejecta. Okay, let's go to the next one. All right. Everybody has a pencil and a paper, all right? We're going to get those big muscles moving, and I mean the one between your ears. So we're going to try. This is how I. You're not going to be sketching this one. I'm going to tell you how I do this. So what I did was I took the one that I did for that I presented in the journal, and I deconstructed it in Photoshop, or I might actually have had Tim do that for me, and then backed it up. So to show, in a sense, how I do it. So when I do a sketch of a lunar feature, trick is focus on something not too big. If you're trying to do the whole, if you're trying to bite off too much, and so you can help people by telling them just focus on a smaller area. Do a little light outline. Usually I say is do the lightest possible outline at first, and then erase it. Okay, now your paper's not clean anymore, and you don't have to be afraid of a blank page. So then go in and draw in the hard shadows that you want to have that. That's the timestamp, boom, of the time you're doing your illustration of the moon, because the Terminator moves across so fast. And then you start adding some more shading and detail, and you can go crazy, and you can go so crazy that the Terminator is actually walking away on you. All right, so if we go to the next one. All right, so what I'd like you to do with your card, you got a blank side on your card there, and you got a pencil. All high-tech tools here. Find a feature on this illustration somewhere, on this image, and draw what you see. Okay? I'll give you 2.4 minutes. man. Okay. All right. So, but see, what materials did we use? If you're stuck for something, put up a slide, give them an index card and a pencil. The point here is when you're going out to do a program, doing outreach or inreach, whatever you're doing, go loaded for bear. If you have basic materials, you can never go wrong. I'm going to show you a couple of slides very quickly in the next moment here, and they're in no particular place in the setup. I just don't know where else to put them. So let's look at these next ones. You find interesting things like this. There's 4 slides coming up here, probably some of the most effective I've ever used in teaching programs, because you talk to people and say, there, look at this, look at the size of Jupiter and Saturn compared to, there's the Earth, tiny Pluto. Let's go to the next one, please. Oh, there's Jupiter. Now, oh my goodness, there's the Earth, there's the Sun. Yow. Right, you're starting to get a sense for the size and scale of things. Let's go to the next one, please. Okay, there's oh, that's not our Sun. Oh, that's not our Sun. Here it is, and Jupiter is about 1 pixel in size. Earth is invisible at this scale. There's Arcturus. Well, does it get any better than that? Oh my goodness. There's Arcturus now, right? So now it's a step up, and you can do it in just a couple of moments, but it's a very dramatic, memorable thing, especially for for young people who are trying to, how do you figure out the size of things? All right, let's go to the next one. Here are some other things that I've done. A lot of these things I just invented because I wanted to have something, but I go low tech. Everything you're going to see is low tech. This is my teabag galaxy. And if you're doing this, I recommend the round tea bags from Tetley. Whatever it is, the consistency of the grains of tea inside, they swirl nicely. And I have a magic star stirring stick there, chopstick, what I always called a magic star stirring stick. And so what you do is you put some water, not too deep in the pan, you sprinkle your tea inside. I only used half that, and a lot of it ended up floating on top. I just took a serviette, and after some had sunk down to the bottom, I took a serviette and just blotted it on the top, and I picked up all the stuff that was on top. Now I could see down at the bottom. I took my magic star stirring stick and just do a slow swirl from the outside and into the inside, very slowly, and all of a sudden that whoosh, 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 whoosh. So now what I can do with this, and because I was smart enough to always have index cards and pencils in my bag, I could tell the people, try your hand at sketching a galaxy. Right? It takes, a little bit of preparation. This is messy. Don't start chucking this stuff when you're finished the program. Don't chuck this stuff down drains. It'll clog the drains. What you need to do is get it outside and throw it into the flower beds. All right? Let's go to the next one. What else can we do? You've heard about kitchen comets, right? This is a street comet. So with the last of the snow that was just around the corner from us, Bridget and I went out and I harvested a comet. Right here. Now it's been melting a little bit. But when you do kitchen comets, and then you use dry ice, and you pour molasses in, and you try to find some volatiles that hopefully won't smoke too many of the people in your demonstration as they're doing it. Why do that? I used to have a number of these in my, because I'd only use these for special programs. I used to have like 5 or 6 of these in my freezer. And Bridget always say, well, we've got no room to put the turkey for Christmas in the freezer. Can we get rid of one of your comments? No. Anyway, so here's one. What happened was I put it in the car the other night. I thought I was going to be coming in, putting it in the fridge, so it would just do to be nice and sloppy and everything like that. And it melted in the car mostly. It was still a chunk. But you can see there's the dirt in here, and I tried to pick out the cigarette butts and twigs, right? Because you don't find too many of those on, all right? But here it is. Kids can come, people can, you pull that out, you can hold it in your hands. I've got a plastic pan that I hold it over. It's something they can, wow, it's cold, eh? Comets are cold. Look at this, I thought it would be a nice, clean, white thing with the tail. Well, this is what does it. Now, it's something that's a hook you can use to start interpreting what it is that you're talking about. All right? This thing was hard as ice. Hard as ice. I'll put that just for the moment. Let's go to the next one, please. Marshmallow Moon. You see Eric here and Eunice at the back. They do video support for our club. When I was going to do this Marshmallow Moon, I was trying to think, what's another way to do a moon? And the way the idea came to do this was we were in that high-end shopping establishment, Value Village, and I find this clear glass plate. what the heck am I gonna do that? Anything that's round, it's gotta be something you could do, you can make a moon out of. Maybe I could paint a moon on it. Maybe I could, and I thought, I know what I'm gonna do. I'm gonna make a marshmallow moon. So, bought a bag of mini marshmallows, and then, this is when I was still playing with cocoa, and I dipped half of them in, put a bag, and I dredged them through cocoa. So now I've got dark ones. So I set up a map like this, and I constructed this. Eric actually has some video of all this. He's doing it the way he's doing now, and projected on the screen so people in the back could see it as it's happening. And I just started creating, and we talk about this sea of tranquility, and and you build up your image of the moon. It's a way to do it. And then if you want, the girls can make and boys in the if you're doing groups like that, they can make their own, and then if they want, they can eat them. They can eat their moon. All right. Let's go to the next one. All right. Aerogel. Fake aerogel. Aero jelly. Right, we were talking about the what was Comet Stardust Mission, right? That trip out to Comet Wild 2. So what happened, right? The spacecraft goes up, and I'm talking to people about this. I had to do a whole talk about this mission at the Science and Tech Museum. Well, I don't just like to yak about things. I want to show people stuff. So I talked about how this tennis racket would pop up as it flew through the tail of the comet, and in the pockets of aerogel, all these comet dust particles were trapped. How can I trap particles in aerogel? Aha, I got a clear plastic bowl. Filled it with a Jello bridge, and I tried some different ones. We have our son Nathan there, and I took a bean shooter, and these navy beans there, or whatever they are, and it went poof, poof, wham, wham. Well, isn't that exactly what happened with this? I mean, you can see that's the real deal up on the upper right there, close-up image of a comet particle. There's our comet particles there. So when I took it to the Science Museum, I had a couple of kids that would come up to demonstrate it. There was one parent there who was, I don't think that's safe to be using pea shooters, and okay, all right. But it was fine. They could see right away what it was I was trying to explain about the Comet Stardust mission. It was too easy. Let's go to the next one, please. All right. And this is an experiment that Tim and I did at a school in Ottawa earlier this year. It's a Life on Mars experiment that I developed. And Bridget and I used to take this into schools. We used to do a whole series of labs for grades kindergarten to grade 6. This Life on Mars experiment, go to the next one, please, Chris. What we do is we set up 3 different containers. One has salt, baking powder, yeast. Here's clean sand, and then I have a container of warm sugar water that I've prepared. So what I get the students to do is they take little containers. I used to use film cans, but of course you can't get film containers anymore. So you go to a dollar bin, you get these little clear plastic shot cups, whatever they are. And what they do is they put a little scoop of sand in each one, and then they take a teaspoon of mystery compound number 1, or number 1, number 2, number 3, and put it in each 3 different cups. They don't know what's in them. They say, oh, that's sugar, isn't it? Oh, that's it. So don't assume. I had a kid who actually put a finger in and tasted one time. I said, oh, I stopped the lab right there. Stop, stop, stop. I said, somebody in this lab, somebody in this room, just tasted the experiment. Now, it looked like sugar, and in fact, or whatever it was, or it looked like salt, and in this case it was, but it could have been bleach. And the faces went a little bit white. I said, it could have been bleach. In your laboratory, you never, ever put anything in your mouth. So let's carry on. Let's see what we're doing here. So you can teach a lesson there too, but without concentrating on somebody. So you add the sugar water. What happens, of course, the one with the salt, it's inert. You get a little chemical reaction from the baking powder, but it's not sustained. But then, okay, as this is starting to grow, and it can happen fairly quickly, but go and do some other activity while their experiment is cooking. So what I'm doing is I'm interpreting a 40-year-old experiment from the surface of Mars from the Viking missions when they scooped up soil, brought it into the easy bake oven, injected nutrients, and saw what's coming off in the gases. Is there any organic life? You know what? Look at this. And what a mess to clean up, I'll tell you. So this is why somewhere I've got a little nitrile gloves, rubber gloves that I put on to do cleanup. Make sure you got a way to tidy up your materials. If you're going in to do a program in a gym somewhere, I always go and find the janitor, the caretaker ahead of time. I say, I'm doing a meteor impact experiment. there's probably going to be a little bit, I'm going to try to be careful, but there's probably going to be a little bit that's going to, and what I do is I take my meteorite, I take my this, and I show them, this is what I'm going to be showing the girls. I do a mini program for the caretaker in 2 minutes. I give them a little pocket sundial. I said, we're going to be making these little pocket sundials. Do you have kids at home or anything like that? Yeah, I do. Here, try this. I have some nice little meteorite fragments that I put on a card. Take one of those along too. You've got a complete ally. If you've done your best to clean up, but you know what? You've left an awful mess. They don't care because they were part of your program. And when I talk to the students sitting on the floor in the gym, I say, now look who's come together to do this program for us. Of course, we need you. Of course, I'm up the front, yak, yak, yak. But we've also had your leaders who made the arrangements for me to come in and do this. But there's also the caretaker. Does anybody know what the caretaker's name? His name's George. I just talked to him. He's got 2 kids. That's great. He's part of the program too because he's going to be able to come in and clean up whatever we're not able to. We're going to do our best. So you bring everybody in. You bring everybody in. Let's go to the next one, please. All right. An easy thing. If you need to buy yourself time, geez, something's gone wrong. You need to set something up. You need 10 minutes just without 30 anxious kids sitting there. You give them a piece of paper and you tell them, okay, I want you to draw 7 dots on here. This is a bit more busier than what I usually use, but I want you to put 1, 2, 3. I want you to put a bigger one there, and I want you to put a couple in a little curve like this down here. And what I want you to do is design your own constellation. This is people, and you tell them in a minute, what did they see in the stars? Okay, this is designer constellations. You're going to design your own. Use lots of color. Let's see what do you see in this? And they start busy drawing, and you get kites, and you get this, and whatever they're going to do, but you've bought yourself time. Then you can go around and see what they're doing, the stars of Scorpius there, and you talk, right? Oh, don't you mean Scorpio? Another opportunity to tell the differences, right, between the astrological signs. Let's go to the next one. Right? Welcome to the Great Intergalactic Conference. This is a game I made up myself for the Association for Bright Children to work so they can do team. It's team building, and actually it can get quite ruthless. So they're delegates to a conference from different galaxies, and they have to have rules. One of them was write down 2 rules for visitors to your galaxy. Oh my goodness. You wouldn't believe what some of these 12-year-olds come up with. And it's, I don't want to go visiting their galaxy, right? Quite draconian. We have this, the little star clocks, all right? So you cut out this one dial, it's on one sheet. You can photocopy them, you take them in. You need the brass fastener. I have one here somewhere, and of course now it's on a paper plate somewhere. It's here, all right? Don't forget your brass fasteners to put them together, right? So what you can do is you can tell by the position of the North Star, or where the North Star is in the middle, there's Cassiopeia, there's the Big Dipper there, and you dial it up for your date and time and hold it facing north, and you can tell and make sure you match up the image you see in the sky with what's on there, and then you can tell the date. Or you can tell the time. It's a clock to tell time. So you set it up for the month, and away you go. So depending on what you're doing, if you're going and doing it around Valentine's Day, so get them to make nice big heart backgrounds, pin it to the Valentine. I've got shamrock templates that I make for St. Patrick's Day, pumpkins for Halloween, you name it. Find an excuse to get them, at the very least, you can get them to cut a big star. Put their thing on behind. You've forgotten everything else. All you brought was your pie plates. Oh no, my little paper plates. But I always have markers and things with me. Look at this. Draw your vision of a moon, right? You can use simple things to do these. All right, let's go to the next one. Sometimes you go someplace and they say, yes, we're going to have everything set up for you, and nothing is set up. This happened to me at the Science and Tech Museum one time. I went there, and they were supposed to have a whole, I forget what the heck it was, but I had my bags. I was always carrying my bags of stuff. I have scissors, I have tape, I have markers, I have a roll of paper, right? I have sheets of paper, construction paper. I have basic materials so that it's basically a Robinson Crusoe kit. If you kick me out of a spacecraft, boop, thump, 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 roll to a stop on the planet. I've got my bag of stuff. Okay, we can start with this. So what I had in the room was I had my scissors. I keep some wax paper in my bin, crayons and scissors and paper, my rolls of paper, and there was nothing there. So I said, okay, what we're going to do is we're going to use these tables. We're going to make spacecraft. We're going to fly to outer space. It was a family astronomy program. It was for, 5, 6, and 7-year-olds. So what they did was they drew pictures, windows, with pictures of aliens or planets, whatever it was. Then we took the big sheets of paper. I had my disposable tablecloths for something like this. I cut holes in them. We taped their pictures on the inside. And then what we did was I dimmed the lights in the room. We crawled under the table. We're playing under the table. The parents are standing on the outside like, all the kids are under this table with Brian, and they're getting the parents to shine a bit of a light, so now we can see these things being illuminated. It was fabulous. But I made something out of nothing. Let's go to the next one. Right? Paper plates. Here's the sun with the rays coming out, and look what they do. They like their projects that they do. Carry sidewalk chalk with you. You cannot go wrong with sidewalk chalks until you have to answer to the people whose institution you've drawn sidewalk chalk on the next day. Right? A native group that I've worked with a number of years that come in from Calgary to the Science and Tech Museum. And after the observatory, I give them some chalk they'd like to draw, and they go crazy. It takes nothing. Let's go to the next one. Simple thing, you want to show the swirling storms on Jupiter. So you get your milk. I powdered milk with some water and threw in some food coloring, just a little bit of a swirl there, and they can start to get the idea. It's a visual. Sometimes just the visual is enough to get people started. The picture on the right, okay, there's Stonehenge. There's a little modeling clay that you can, this foamy clay, have them make models of Stonehenge. Right? People have different levels of ability they like to do, but everything is, they're interpreting it for themselves. Let's go to the next one. How easy is that? Let's go to the next one. Look at this. I had to do a program on the Aurora. How am I going to make an Aurora? Too easy. Styrofoam plate, skewer, put a nice, what do you call this material that you buy at dollar bin? Right, different colors around. There's the sheet, the curtains, and there's the sun. There's one on black holes. Jets coming out, right? Everything's swirling down to the event horizon. Here's down below. Right? Let's go to the next one. Saturn. And they even put a button, somebody added this, they put a button on top that said, I heard there was an Aurora on Saturn. Right, perfect. And then we made little stamps out of foam. And then you bring your ink pads and boom, boom, boom. It's another way to do things. You could stamp their passports. Any idea that you could pull together. Let's go to the next one. This is name a star. Who is hostile about this name a star business? There's a lot. Yeah, there's a lot of that. But you know what? It's not going to go away. So what you have to do is use it as a teaching moment. This is outreach. People buy these things, and you have to look at what the purpose is. As long as I think that a lot of them have dialed back from saying, yes, this is an official star name, right? People are buying these things as memorials. So it's like buying a birthday card, but with a bit more gravitas to it that they feel. So when somebody comes in at the Science Museum and they say they want to see where their star is, you know what I do? I work in theater as a stage manager. I dress the set. I have the star charts out. I'll have the candle lit. I did one for a family, a young couple that lost a baby. And they named it, that's not this one, but they brought in the charts and everything. I did my research to find out as close as I could in my different levels of star charts, which actual star they were looking at. And I interpreted what it was, what the constellation was. I gave them some context. They were coming in needing something, and I gave them what they needed, right? This is something else. That's a couple that came in to do a surprise for his fiancée. He was going to propose to her that night at the Science Museum. So, and she gets there and she's kind of wondering, she knew they were coming for an astronomy program, but is it just the two of us? I talked about the Heart Nebula, the Ring Nebula, right? All this kind of stuff. He's killing himself. She's got, great. So then I said, and at the appointed time, I left him in the observatory. I said, would you excuse me a minute? I have to go get something from the museum. I went away. Then I hung around in the lobby, and then about 5 minutes later, phone rings. Brian, come on in. And she's there with her own Ring Nebula on the go. So you can use whatever. Okay, let's go to the next one, please. And this is the last slide here. I mean, it's whatever inspires you. Let it drive you. Let it really inspire you. Use that inspiration to inspire others. All right. So now we're going to get cracking here. Eric's got the camera on the go. This is good. And, hey Simon. So what we're gonna do is we're gonna do our little meteor impact experiment right here. And I'll get the other mic, okay? Anyway. And then we're gonna do a draw and then we're gonna have coffee right after. This is fairly quick. Okay, so I need my helpers. I've got Tara, I've got Ilias, and Ruby, you're gonna come and help me here? Okay, we'll get. All right, can you give me the microphone there, please? Thank you, we're good to go on this mic? Okay, that's good. Okay, take one of these. Take one of these. And, oh, you're old, you get a bigger one. She gets a bigger one. All right, so what we've done is, okay, so I told you how I set it up. When I'm doing the program, right, I set it up first as the land before time. It's a time when dinosaurs roamed the earth. So I've got the dinosaurs, okay, these guys have set up the dinosaurs. Who put the pterodactyl in the tree? I've never even thought about doing that. You learn every time. This is what makes it all work, right? You grow and learn. All right, so now this is the land before time. I have a map that I talk about the impact in the Yucatan, right? You interpret, you show them where it happened, and then you talk about it. I use my my slice of KT boundary, and I show them this is it. You're holding this right in your hands, evidence of the impact that killed off the dinosaurs. That's part of the story. That's the main part of the story. And so I talked about, a little bit about the dinosaurs, not too much. Then I say, okay, so this is what we have. We talk about the impacts. We talk about asteroids coming in, all right, flying in from outer space. I'm going to use one that Kenneth gave us here. These are too good. All right, these things coming and flying in, the impact of impacts. So you do it in a way that they're going to understand. Okay, so now what we're going to do is we want to really, what else do we see? Where do we see impacts? On the moon. Okay, what we're going to do is we're going to take away these dinosaurs. So let's start doing that, you guys. Start picking away the dinosaurs and the prehistoric trees very carefully. And except for my big dinosaur, which I need on the rock, he'll come off too, but you guys can each take a dinosaur to take home. So that's what I do. I go to Walmart, I buy bags of dinosaurs. I've gone through more dinosaurs. I have regular shipments from Walmart. There are dinosaur deliveries. All right? Because what I do is I send the kids home with a dinosaur. And when I've got adults doing the program, I send the adults home with the dinosaur too. Just as something to think about. And oh yes, I've got something I can give it to at home. Right? That's good. Okay, we'll move to our little, okay, yeah, we'll leave some lunar rocks there. So what we're going to do, we're going to start doing some impacts. So we're going to start with one, not in the middle one though. Let's start with this black one here. I want you to go in, no, this one right here actually. Let's start with this one. Give it, now when you do it, and the way I'm telling you is the way I tell the people. We're going to do a hard shot. It's got to go boom down in there, but I don't want any overhand stuff because what's going to happen is it's going to miss the pan, it's going to bounce on the floor, it's going to poke her right in the eye. Okay, give it a good shot there. Go, go. All right, go ahead and do yours right alongside it. Hard, hard, hard. Ruby, same one. All right, so what we can do now, we start to interpret what we're seeing here. Okay, and we can see how some of the ejecta's gone out. Right, we can see the lighter color material from underneath going over, so now we can start to see it. If I were to do one, say in this one, I'll do another one here, like that. And you can start to see how, you can even see some of the terracing inside the walls, the crater walls, some things slumped down, there's material slumped down on the bottom. You can show them what they can actually look at through a small telescope and see on the moon. All right? So we're going to do, let's get some marbles again here. Go ahead, pass this around. I want you to give a few more shots. Does anybody want to try it? Anybody else, if you want to, come now. Okay. Oh, mommy. Okay. All right. So we'll save the black one but let's do some in the red. Let's get going. Let's get some action going. We'll save that one in the middle. Okay. You can take your marble, give it another shot or two. Go ahead. Go again. Doesn't stay in there? Yeah. Yeah. Go ahead. Sure. Yeah. Except for the middle one. Except for the middle one. I'll save this one just for. Yeah. Go ahead. All right. Yeah. Go ahead and take yours. Yeah. That's all right.
That's a nice crater.
That was a low angle impact there, so you can, everything works, right? The mistakes work, everything works. Okay, go ahead and do some more. Let's get some to go in that pan over there.
Can we use the moon rocks?
Try the moon rocks. Okay, get right close to it, yeah. The moon rocks, okay. All right, so now what we can do, some people don't, and what you're gonna find is some people don't have good aim. All right, So what I'm going to do now is, of course, now you guys have been playing with those little marbles. Now it's my turn. Oh, you want to throw that in one of those, in the blue. So now it's my turn. This is a croquet ball without the covering. Croquet ball without the covering. So what I'm going to do is stand back. Stand back. All right. So I'm trying not to mess up everything here because we're going to interpret this in a second, but oh my goodness. Here we go. 5, 4,
3,
2, 1.
There's one. And I'm going to do another one here. 10, 9, 8, 7, 6, 5, 4, 3, 2. Oh, cover.
That was the dinosaur.
That was a dinosaur. Okay. They're trying to make too much of a mess. Ruby, do you want to do one on with this?
That was
Right,
like Tycho.
Oh, it's dirty. I'll do a. All right. So we can get some of that on the go. So now what we're going to do is we've made a heck of a mess here, and look how far the ejecta actually has gone from that one that I did over here. It's gone all the way over here, and you can see rays like this when you look at the moon. Right on the carpet, you'll see down there. See that? So there is an effect to an impact. So now what we're going to do is we're going to slide these off to one side, Ruby, and let's try not to disturb too much of what we've created on the floor here, but let's just move them off to the side. Okay. And for those of us who aren't 50 anymore, these kneeling pads are a lifesaver. You throw that down. Actually, this is the first time I've stopped it in like 4 days. Okay, so now what we can do is we interpret what we see here. I can see that there's black on here. I can see that there's red ejecta on top. So we know, if you looked at this carefully, you can start now to interpret the order of events. You can even see, oh, and there we put our lunar lander there. So now we've created this lunar scape. When I did this in England in 2003 for the, or 2013 for the West Yorkshire Astronomical Society, some guy comes along with his phone and he puts it down at a low angle and he starts doing a flyover. And took a little video and he shows me this video. I hadn't seen him actually do it. And he says, oh, he says, hey, look at this. That's the way he talked. Hey, right? So he showed me and there's this, and it looked like somebody flying over the moon. I thought, wow, what a different way to do this. So now, I mean, if you want to, bring your camera down, and I'll leave it set up for a minute because we're going to be going to coffee in a minute. But we'll go to coffee in just a minute. But you can go and take some images of this and see what you can make out of it another time. We have one more slide there, I think, Chris. That's going to be it for the video. Eric, thank you. That was A1. What we're setting up outside, Gordon and Julia. Okay, yeah, okay. They're set up outside. And what we're going to do, this is an activity I did at the RASC meeting one time. Map of the moon, blank circle. There are drawing materials. Julia's out there, she's got the drawing materials. Yeah, they're all set. And what you're going to do is take a moment and draw a bit of a lunar feature. What they're doing is did you have your camera set up for, is the camera set up out there as well?
We're going to do it during the lunch hour.
Oh, during lunch hour? Okay, so during the lunch hour, just before we break to go over to the lunchtime. At the other in the other building, you can start making up a map of the moon. What we're going to do is we'll have a camera just fixed. So as you come up and do this, and put your little, I think I'll draw that part, well, I'll draw this part, different colored markers there. Then they'll put together a quickie video of this, compressed time, so we're going to look like a bunch of Keystone Cops putting a moon map together. We'll show that at the banquet.
You're going to do the lunar far side as well?
Lunar far side, yeah, you do that one. You do that one. Okay, any questions about what we're doing? Who had the idea, who was mentioning about the other way of doing the material for the impact was using? Cinnamon, what was it? Paul?
I do a mix of baking soda and flour, 50-50 mix of baking soda, and I use a plastic tub, and you get the full rebound. So you get ridging form, you get center mountains, and you get the ejecta splash, because I use either cocoa or cinnamon on top. But with a plastic tub, you get a perfect rebound with whatever you use. And it's a great mix. And the other thing, you can add a little milk and flour or egg, and quickly throw it in, and you've got a moon pie that still has a crater in it when they're cooked. Yeah, so I do that at guide camps.
Okay, that's great. That's great. Okay, anybody else have any comments or any questions? Yes?
What's the worst thing that's gone wrong as you've been doing this stuff?
The worst thing?
The worst thing that's gone wrong?
Probably having me as a presenter. What? I don't know. I don't remember.
That's good.
Well, I guess it's the, well, you know what it is? It's the, I don't think I've had stuff in a sense go wrong. Because if you start to see something, like say this was, something's not gelling with your audience, you know what? Don't slog it out. I say, you know what? Let's do something else. Cut and run. Okay, your pride isn't there. Haul some, this is why you go loaded for bear. Haul something else out of the bag. Haul something else out of the bag and get rolling with it. So the worst thing in a sense that's ever happened is when I arrived at a place and there was nothing set up. That thing that happened at the Science Museum one time, and also I went out to a camp to do something as well. But this is why, and I learned after that, you know, I always am self-sufficient. I don't require electricity. I don't require anything. I've got all the materials that we need. Richard.
KT boundary on Earth, sorry, KT boundary on Earth, they find iridium too.
Yeah.
And they find the lunar craters as well.
Yeah. Well, this is why. Sorry, this is why on a piece that I interpret,
Yeah.
we've got it showing what there's a fireball layer, there's the ash layer that's chock full of iridium.
Yeah.
And that's another aspect that you can bring out to it. So you can decide how detailed you want to be. All right. Anything else? Okay, that's it. Okay. We're ready.